this unit is on solving quadratics, so we're going to learn something called factoring. But before we can do that, I want to talk about the most simple way to solve a quadratic. So before we do that, we need to know what solutions are. So I gave you a bit of a hint here, but if you turn to page 48 in your notebook, I'd like for you to tell me what are the 4 different names for a solution, okay? So look at these vocabulary words, see if you can find 4 different names to solutions for quadratic functions, okay? All right, so now that you've looked at it, and hopefully you checked the right answers, it's x-intercepts, roots, zeros, and solutions. All 4 of these words mean exactly the same thing, okay? So it's x-intercept, roots, zeros, and solutions. Maybe x-intercept should have an S since everything else has an S, okay? And so essentially what this means is that you're just going to try to find where it crosses the x-axis. Okay, so here we are. Here's our graph, and you can think of a tree. The roots start on the x-axis. So if it asks you for the roots or the solutions, they're saying, hey, where does this touch the x-axis? Okay? So a quadratic graph can have 3 different types of solutions. And we talked about this on the first day as well. Remember when we did this page and we asked how many roots, zeros are solutions? And what you were doing was looking to see when it crosses the x-axis. So like this one would have 2, this one would have none because it never touches the x-axis, and then this one would have 1 because it only touches the x-axis in one place. Okay? So if I wanted to show some examples of 2 solutions, maybe my graph would look like this. 2 solutions because it touches the x-axis in 2 places. 1 solution might look like this because it touches the x-axis in only one place. And no solution would mean that it was above the x-axis or maybe below the x-axis, but it never touches that x-axis at all. Okay? All right. Next, there are 5 different ways to solve quadratic equations. The first one is to look at graphs. And when you look at the graphs, you're just going to look at where does it cross the x-axis. The second one is to look at tables. And so this one you look at where it crosses the x-axis. And the second one is tables. So if I'm looking for an x-intercept, I'm looking for when y equals 0. Today we're going to talk specifically about graphs and tables, okay? The third method is about quadratic formula, okay? And we'll do that later on, but I just need you to know that is another method. And then there's something called factoring. And lastly, there's something called completing the square. So there are 5 different ways that we can go about finding the solutions to a quadratic equation. Okay? So on the inside here, I'm going to start with probably the easiest ones, which are graphs and tables. Now if you look, my graphs aren't graphed at all, which means it's going to be a little bit harder than just looking at the table. So what did I say? If I want you to use a table to solve, what are you going to look for in the table? What did we write on the front of this foldable? We looked for when, so we're looking for the x-intercepts, so we want to know when y is 0. Remember, the x-intercept is when the y is 0, and the y-intercept is when the x is 0. So you're literally going to look at this table, and you're going to go, okay, I'm going to look for when y is equal to 0 in my table. Oh, right here. So my solution is x equals 5. Okay? Another way to write that is I could say 5, 0. Either of those would be accepted as solutions to this problem. All right, look at number 2. So we're looking for when y is equal to 0, so I see it here. And then moving on down, I also see it here. So if you notice, this table has 2 solutions. So I'm going to write x equals -2 or 3. Okay? Now that's if I wanted to list out just what the x value was, but sometimes they want to know the ordered pair, so you might say -2, 0, and 3, 0. 2 points. Okay? The last thing it asks you to do is make a table to find the solution. Alright, so how do we make a table? We go to our handy dandy TI-84 Plus graphing calculator, clear everything out, push y equals. Where it says y equals, there might be something there. Clear that out as well. Then you type in your equation. X squared minus 7x, 7x plus 6. Okay? Then you're going to go ahead and look at the table. Remember to look at the table. That's the blue thing above graph. So you push second table. And then you're just going to try to find if there's any pattern, okay? Because once you found the pattern, you know you found them all. So I'm looking and I see a pattern, -4, -6, -6, -4. So I can see 2 zeros as solutions on my table. So I'm going to write all of those things down on my table. 1, 2, 3, 4, 5, and 6. Okay? So you want to try to make sure you find all the parts of the table that have zeros. And so when y is 0, remember this little f of x right here really just means y. Okay? Alright, and so my solutions are x equals 1, also 6, or you can say 1, 0, and 6, 0. Now if you write your x's 1 and 6 like this, you technically should put this to show that it is the set of and not an ordered pair. Alright, so that's using a table to solve. The next easiest way is to graph it and find the solution. Now remember, there's several different ways to graph and find solutions to the problem. The first way is to flat out go to y equals on your calculator and type in the equation. So it's x squared plus 4x minus 5, and you can push graph and see how many solutions does it actually have. And in this case, it looks like it's going to have 2 solutions. I'm going to go to zoom standard, so if you push the zoom button and standard, that's going to give you the normal window that you see, the -10 to 10 and the -10 to 10 on the both axes. Okay? So, I mean, you can sort of graph it this way, but I can't really see the exact points. And it looks like my vertex is going to be, this black box right here is meant to be my vertex, right? So it looks like it's going to be at -2. So let's look at the table to see exactly where it's at. So when we look at the table and I arrow up to -2, do I see the pattern at -2? So it's got -8, -8, -5, -5, 0, 0. So that means that's my vertex. So -2 goes in the middle, and then you just copy down. Whoops, I copied something down wrong. Shoot. At -4, it's -5. And then you just go ahead and graph these points. So it's -2, -9, -1, -8, 0, -5. And if you notice, I always start in the middle and work my way up. Alright, so now let's do the other way. -3, -8, -4, -5. So as of right now, I can't see my zeros on my graph. So I'm going to have to go on my table and go up a little further and get a couple more points, right? So let's see. Sorry, I got lost. Okay, -4, so -5 is 0, right? So I'm going to put a point right here at -5, 0. So I found one of my zeros. And then that looks like it must mean that 1 is also going to be 0 if I go on the other side of my table, because they're matching points. Okay, so my answers are -5 and 1. Remember, use little squigglies, so -5, comma 1. Okay? So when you write your answers, make sure you use that little squiggly sign. And I should have done that here on number 2 as well, sorry. So go down to here and add that in there. Alright. Number 2, we're going to graph it same way we did. You can use that -b over 2a if you would like, or you can just graph it and see if you can find the pattern. So go to your graph. And so it looks like my vertex is going to be somewhere around like maybe 2 for the x. I don't know. So let's go to our table. And go ahead and copy down your table. But make sure you can kind of see your vertex. We said it was probably around 2. And it's not. It's actually around 1. Because I can see the pattern. 0 is in the middle of the pattern. 1, 4, 9, and then 1, 4, 9. So that 0 is there. So 1, 0 should be in the middle of my table. That shouldn't be 9. I don't know what I was thinking here. Sorry. My brain's not all here right this second, apparently. There. Okay, so now my table is correct. Now I'm going to graph my points. Remember, I always start in the middle. So 1, 0, 2, 1, 3, 4, and then -1. Alright. I forgot 0. Look at my table. I forgot the 0. Okay, let's see. 1, 0. And then -1 is 4. No. I forgot the 0 right here. Sorry. Clearly can't copy a table today to save my life. Okay. So on my table it's 1, 0, and then before 0 it's 0, 1, and then -1, 4. I'm sorry, I wasted some time. Okay. So 0, 1 would be, and I knew I was wrong because, like, remember we're supposed to have these matching points, so I knew I had done it wrong. So you can always tell if you did it wrong with quadratics because you got your matching points that are supposed to show up. Alright, so my solution to this one, it only has one solution, so we say x equals 1. Okay? And it doesn't need the squigglies because there's only one answer. The squigglies means the set of, so if there's more than one answer, it needs the squigglies. Okay, number 3. So number 3, we're going to graph it again, and we're going to take a look at it. It says -x squared plus 2x minus 3. So then we're going to push graph, and we're going to see what our graph looks like. Oh boy, this one looks like a negative graph or a frowny face, and it's not ever going to touch the x-axis. So what did we say when it never touches the x-axis? We call that one no solution. Okay? So this one we say no solution. But let's go ahead and get the table and the graph for this one, and I'm going to let you do that on your own. Okay? And I'll come back and show you the final product. Okay, so when you're done, your graph and table should look like this. The last concept we're going to talk about today is using factors to solve. So factors are numbers that you multiply by. Okay? So if I were talking about, like, let's say 2x equals 0, the only way for 2 times some number to be 0 is as if this x is 0. Okay? If I said 3x equals 0, x would have to be 0. If I said 100x equals 0, x would have to be 0. If I said x times y is 0, well then I'm saying that one of these two numbers has to be 0. Y could be 0, or x could be 0. Or I could say that both x and y are 0, because 0 times 0 is 0. Okay? So if you look over here, these signs, it says parentheses x plus 3 and parentheses x plus 1. This operation in between the two of them is multiplication. So what that means is x plus 3 has to be 0, or x plus 1 has to be 0, or both of them have to be 0. So what we're going to do is we're going to solve this by saying x plus 3 equals 0. We're going to go over here and we're going to say x plus 1 equals 0, and we're going to get two solutions. So x plus 3 equals 0, we're going to subtract 3 from both sides. X equals negative 3. Here we're going to subtract 1 from each side and get x equals negative 1. So my solutions are x equals negative 3 and also negative 1. And we have to put the little squigglies here to represent a set of numbers. Okay? So you just take each of these factors and you set them equal to 0. Alright, let's do number 2. So problem number 2 says x times x minus 8. So if you look at it, we could even go and do that thing where you say, okay, here's the first factor, here is the second factor. Okay? So that means I'm going to say this first one, x equals 0, and then this second one, x minus 8 equals 0. This one's already solved. This one we have to add 8 to both sides. So you get x equals 8. Okay? On the third one, we have this first factor, x plus 8, and this second factor, x plus 8. So we're going to solve both of them. X plus 8 equals 0, and this one, x plus 8 equals 0. Well, aren't these both the exact same problem? Yes. So since they're both the exact same problem, this means I'm only going to need to solve one of them. So x equals negative 8. If I solved this one, I would also get x equals negative 8. So there's only one solution on number 3. Sorry, number 2 had two solutions. Number 1 also had two solutions. Now remember, you can write your solutions as a list with the little squigglies, or you can write your solutions as x equals and x equals. Alright, number 4. The first factor is 2x plus 5. The second factor is x minus 1. So we're going to set the blue one equal to 0, and we're going to set the orange one equal to 0. Now, I'm pretty lazy. I always solve the easy one first. Plus 1 to both sides. Okay. Over here, 2x equals negative 5. Then I still have to divide by 2. X equals negative 2.5. Okay? Alright, go ahead and get the answer to number 5 on your own. Alright, there's the solution to number 5. And now you do 6 on your own. Alright, there's the solution to number 6. Now remember, on number 6, it's 3 times x equals 0. So I would divide by 3 on both sides and get x is just plain old 0. Remember, anything times the number 0, that means that number has to be 0 in order for it to work. Alright, thanks so much for watching. Have a nice day.